Okay, in today's class, we are going to find the first and the second partial derivative for the given function. The function is f of x comma y is x cube plus x square y cube minus 2y square. Okay, so finding the first and the second derivative means I have a function. First derivative means it will be, since f is a function of x and y, the first derivative would be a function with respect to x and a function with respect to y. These would be the first derivative. Now coming to the second derivative, x can be again differentiated with respect to x. So this is one of the second derivative. X can be differentiated again with respect to y. So this is one of the derivative. Again coming here, y can be again differentiated with respect to y, and y can be differentiated again with respect to x. Okay, so what we observe is the first derivative, we have two first derivative and four second derivative. Out of the four second derivative, these two terms fxy and fyx, they would be equal. Okay, so it is enough if you either find fxy or fyx. Okay, but in this example, we'll check whether fxy and fyx are both same. Okay, f of x comma y is the first derivative we are going to find. So a function with respect to x. Okay, so here I have x cube. When I differentiate x cube with respect to x means I'll get 3x square. Now coming to the second term, I have x term and a y term, but my differentiation is with respect to x alone. So y would be treated as a constant. So whenever you're doing your integration or differentiation, your constant, you'll keep it as such. Okay, only the function would be differentiated. The differentiation of x square is 2x. Now coming to the third term, I have 2 as a constant. Again, I have y square. Again, you can see that 2 and y square, it is derivative with respect to x. Okay, so I don't have any x term here, so this would become 0. Okay, so first derivative is over for x. Next, I'll find what the second derivative of this is, fxx. Okay, so I've already found fx. Okay, already found. Again, I'm going to differentiate with respect to x. So differentiation of 3x square is nothing but 6x plus differentiation of 2x is 2 and y cube is a constant. It comes along the function. Okay, this is fxx. Okay, so this is also over. I need next what is fxy. So fxy means I already have what is fx. I have to differentiate again with respect to y. This is my fx. I'm going to differentiate with respect to y. The first term doesn't have a y term because my derivative is with respect to y. So the first term will become 0. For the second term, x is a constant. 2 is also a constant. Derivative of y cube is nothing but 3y square. Or I can write it as 6x y square. Okay. Next we have to find, so this is also over. Next we have to find what is fy. Fy, this is a function. We have to differentiate this function with respect to y. Okay, so this function we are going to differentiate with respect to y. First term is x square. We're differentiating with respect to y. X cube is a constant. Differentiation of a constant is 0. Second term, I have product of two terms. So x square is a constant. Derivative of y cube is nothing but 3y square. Next term is 2y square. Derivative of that is 4y. So this is equal to 3x square y square minus 4y. Okay, next you have to find what is fy is over fyy. Fyy, again you have to differentiate your y again with respect to y. Okay, so here 3x square is a constant. Differentiation of y square. Differentiation of y square is 2y. Already a 3 is there. So it will be 6x square y minus I have 4y. Derivative of 4y is 4. Okay, so this is also next fyx. Fyx, I write it like this for understanding. Okay, so fy is already there. You have to differentiate again with respect to x. Okay, so when you differentiate with respect to x means it will become 6x y square, and the second term doesn't have an x term, so when you differentiate with respect to x means it will become 0. Okay, so you know that fyx is equal to 6x square y, and you observe that fxy is also 6x square y. Okay, so fyx is equal to fxy. So it is enough if you find fxy or fyx. It is not necessary to find both.